Carl Schultz, President of Packline Corporation. We're here in Packline's demonstration lab today, and I want to have a discussion about conveyor chain maintenance. Like any other piece of machinery, if not maintained, its life can be shortened. So I want to go through the most important points about this conveyor, but it's also valid for any other type of overhead conveyor. First, let's start with lubrication. An overhead conveyor is a style of conveyor that utilizes a conveyor chain running in a track, just like this. As you can see from the chain, it's a series of bearings, pins, and linkages. And these require lubrication, proper lubrication over the life of the equipment. A conveyor system such as our C250 should last 10 to 20 years easily in an application. Quite often we find that systems wear out quicker than that, and upon inspection we find that lubrication is the culprit. Each one of these pins in this chain will require some lubrication. The bearings themselves will require some lubrication. Quite often we'll service a system and move the bearings just by hand like this and find that they are excessively sloppy. That's a sign of either overloading or lack of lubrication. The same holds true for the pins. If the pins aren't lubricated, of course they're going to wear. And when they wear, the chain will get longer and longer and longer. And in each foot of chain, you have about 4 of these chain pins. And even though they're only wearing about 5 or 6 thousandths of an inch, over the length of your 1,000-foot long conveyor, that can add up to a significant amount of inches. And eventually they'll get to the point where they can no longer be pulled through a drive unit. So we want to make sure that your system gets adequate lubrication. Each system that we sell comes with some form of a lubricator. I have our model 375 lubricator here. It's a brush style lubricator. Lubricant is put in this reservoir on the top, and when we tell it to by opening a switch, a solenoid operated device here, oil will flow down into this brush, and this chain is being pulled through and under this brush. So lubricant gets transferred onto the bearings and chain linkages that way. This lubricator has a shuttlecock on it to slow down the flow of oil to suit the system. If you have a very slow moving system, you don't want too much oil flowing through that brush at any given time. And a long system running very fast, you'd want that opened up so that more oil is flowing through. It actually has a sight glass on it where you'll be able to see oil drops forming and dropping down to the brush below. So this will have to be adjusted by either Packline crew initially or maintenance staff as the system is put into operation. There are many variations on these lubricators, some with more brushes, some which are shot lubricators where we either put compressed air to it to shoot the lubricant onto the chain linkages. That's often considered one of the best ways to positively get lubricant to the bearings and chain pins. The oil that goes in these lubricators is very important. Packline manufactures lubricants to suit our applications. Quite often we put tackifiers in that lubricant so that lubricant stays on the chain components longer than an average oil would. And that's very important. You don't want oil to be dripping out of your system. What is the correct amount of oil? Well, usually when our installers leave the installation site, they will have properly lubricated the chain by running it through the lubricator many times until they see oil starting to form on these chain pennants. Now remember, these are hanging through the bottom of the track. So once we see oil starting to form on these chain pennants, we turn off that lubricator, and we usually will take a rag and wipe off the excess oil from these chain links. From that point forward, we have to leave it to the customer to establish a proper lubrication interval. What I suggest to customers is run that system until you first hear the first signs of squeaking of a chain bearing. Then back off that interval. Let's say that was 2 weeks. Take a few days off and say, okay, at 10 days, I'm going to re-lubricate that system. And then turn that lubricator on for 2 or 3 cycles of the conveyor chain. Turn it off again, and then wait 10 more days. And during that period of time, monitor how much oil, if any, is flowing down these chain pendants. We don't want to have lubricant on the floor or on customer product, so it's very important that we monitor it. And once we do find that interval, we stick to it and make sure that if the system's off, we're not, turning. If the system was off for 2 weeks, we wouldn't turn the lubricator on. The last time it was shut off and the first time it was turned on. We have to make sure that the lubrication is correct for the application. And it's different for every customer, so we at Packline can't determine that very easily at the outset. Okay, let's move on to probably the number one problem we find with our overhead conveyors. We get a service call and we go to site, and 90% of the cases we find that it has to do with improper tensioning of the take-up unit. Now, a properly designed system will have a drive unit at a high elevation and a take-up unit located as close to that drive, and quite often after the first decline from the drive. So you have your drive up high, and we have your take-up down low. Why is that? Well, we want the chain to be naturally pulled out of the drive. I have a drive on the table here, and we'll discuss exactly what can happen to make that drive malfunction. But the biggest thing is that the take-up unit isn't working properly, therefore chain is bunching up in the track. So if this chain isn't tensioned properly, it really has nowhere to go. It is stuck in this round track. And so what happens? The chain turns sideways. It's trying to shorten its pitch, but it's got nowhere to go. So it turns the chain pendants, these are chain pendants, they turn sideways and they slide on the side of the track. And quite often they'll wear a piece of track, so we'll find that the track slot between the drive unit and the take-up, and that is where all the slack chain bunches up, causes the slot in that area to get wider and wider. And you can quite often see some evidence, for example, some shavings of metal filings on the floor,